Hello everyone. As part of learning Big Data Hadoop framework, let us come to learn the concept of Spark. So let us see what exactly is Spark and how does it differ from rest of the components of the framework and where it is helpful for us. So as an introduction to Spark, just go through these things. It's a cluster computing framework which can So where is the Spark differing with MapReduce? Let us just quickly look at the fundamental differences of MapReduce and Spark. It's a cluster computing framework for large scale data processing. So the moment I say large scale data processing, we need to see MapReduce is also a processing component. So let us quickly compare both of them. Spark does not use MapReduce as its default execution engine. What do we mean by that? If at all we were learning Scoop, we were learning Pig, whatever command we give, whatever statement we give there, it automatically executes internally a MapReduce program. So undercurrent for Scoop and Pig, there is MapReduce. It is automatically building the MapReduce programs for the commands we are giving. But whereas when you are trying to work with Spark, underlying it will not use MapReduce processing, it has its own built-in execution framework. So Spark has its own distributed runtime for executing the work, right? This is the first difference. Rest of the frameworks, rest of the components of Hadoop, they will be using MapReduce as the underlying execution engine, whereas Spark has its own distributed runtime environment. Then Spark is closely integrated with Hadoop. It can work with Yarn, it can work with various types of file formats, and it can also try to take files from the HDFS, just like MapReduce. Maybe this is not a difference between both of them, it is a similarity. So we are trying to see what both can do, right? Spark is best known for its ability to keep large working data sets in memory between jobs. This is the greatest advantage Spark provides compared to MapReduce. Whenever we are working with MapReduce, if I have to process a data set, say for example, I have a data set of 2 GB, right? Whenever we are executing the MapReduce program, the 2 GB data set has to be loaded into memory from the HDFS. Every time that huge amount of data should be loaded. Whereas when you are working with Spark, it has the ability to store the data set in memory, just like a cache memory. It can store it there until some time. So you are trying to reduce the amount of time needed for loading the data into memory. This is the greatest advantage. See, we might argue how much time does it take to load the data. We are just talking about smaller amounts of files, fine, there is no much time for loading the data. But when we are working with huge amounts of data set, that happens to be a considerable amount when we are trying to load data every time we are executing the job. So Spark has the ability to hold the data in memory for some time, which we try to talk about under the persistence concept, right? This capability allows Spark to outperform the equivalent MapReduce where data sets are always loaded from disk. This is what I was talking about. Whenever you are working with MapReduce, the data sets are always loaded from the disk, whereas when you are working with Spark, it has the ability to store them in the memory for some time. Then when you are working with Spark's processing model, it has two types of processing model or two styles. First one is iterative algorithms, second one is interactive analysis. So it can do two types of styles whenever it is trying to execute the applications. Also, unlike MapReduce, Spark's DAG engine, directed acyclic graph, a DAG engine can process arbitrary pipelines of operations. Suppose I try to specify addition, subtraction on a particular set of items, or I have specified join, I have specified union, I have specified intersection, various types of operations on various data sets. So how do I try to execute them? Whenever you are trying to work with MapReduce, maybe it follows the order in which we have specified those operations, whereas Spark will try to design a directed acyclic graph, and it will try to put the operations in a specific order, which will try to reduce the amount of execution time, and it will try to give the best answer. So it has to build, or it will build, a directed acyclic graph, and it can execute the arbitrary pipelines of operations and translates them into a single job for the user. It will try to combine all these operations in the best possible way, and it will try to convert it into a single job. Then Spark also has a rich set of APIs, and which will try to do various common data processing tasks, and it has APIs majorly in 3 languages: Scala, Java and Python. I will show you 1 or 2 examples, one particular task written in Java, written in Python, written in Scala. So if we go through the prescribed textbook Hadoop definitive guide, most of the code they try to use the Scala notation, and very rarely they try to show you Java notation. Only for comparative purpose they will try to show the Python code also. Now Spark comes with a paradigm, we call it as read, evaluate, print and loop through these operations. I want to read the data, I want to do some evaluations, I want to print the output, and I want to loop through these operations. For both Scala and Python, which is very quick to explore the huge amounts of data sets. Spark also has a very good library which is integrated into it for building analytic tools to work with machine learning. It has built-in libraries for all these applications: graph processing and stream processing, and to work with SQL. So Spark is trying to cover up various domains, and it is trying to spawning various domains so that the job becomes easy for the user. How do we install Spark? Go to downloads page, try to take the Spark and give the tarball, and these are the binaries to be adjusted. Now, a terminology associated with Spark, just let us see some of the terms. Spark, whenever you are trying to talk about Spark, people talk about applications, jobs, stages and tasks. So let us quickly see what exactly these terms are. In some of the programming paradigms, they might seem to be interchangeably used, but here we try to differentiate them. Spark has the concept of a job. Whatever work I submit, say for example, I have given an employee data set and I wanted to find out across the organization who is the employee who has obtained huge amount of increment, right? My organization could be spread across various various geographical locations of the world. I wanted to find out which employee has got huge increment, or who got the highest increment in a particular appraisal period, right? So whatever work I have submitted to Spark, that will be called as a job. So Spark has the concept of a job. A Spark job is more general than a MapReduce job, because in MapReduce also we call it as a job. In Spark it is a generalized term, since it is made up of an arbitrary directed acyclic graph of stages. The moment I try to give a job, we try to divide it into stages. So this is the next word, stages, each of which is roughly equivalent to a map or reduce phase in MapReduce. Here I would like to take a small example or analogy. Suppose you are trying to work with the join operation in SQL. The same join operation can be performed in MapReduce also. Say for example, I am trying to extract data from 3 tables, right? Join is an operation where you are trying to extract data from multiple instances of the single table or single instance of multiple tables, right? So whenever I am trying to extract my data from multiple tables, say for example, employee table, department table, and I want to work with EMP SAL. There are 3 tables, say for example. When you are trying to extract data from 3 tables, what shall I do? Which table first I should consult to get the data, then which table, how do I process my subqueries, or which 2 attributes should I use for joining, should I go for outer join, should I go for a left outer join, what type of join do I expect. So you are trying to divide the given job into stages. In our terminology of MapReduce, which is known to us, it could be equivalent to, a stage is equivalent to either a map or a reduce phase. Stages again are split into tasks. Job split into stages. Each stage is split into task by the Spark runtime, and these are run in parallel on partitions of an RDD, stands for resilient data distribution or resilient distributed data set. So Spark has RDDs which are spread across the cluster. Now try to understand, a job is there which is divided into stages. Each stage is split into tasks, and these tasks are running parallelly on the RDD. I will talk about RDDs very soon. A job always runs in the context of an application. What do we mean by context? Whenever you are trying to work with parallel jobs, all of them should give their individual results into a common area wherein I can try to consolidate. So that is the context of the application. All the jobs which are running their tasks in parallel do have a common context. This context is represented by the instance of Spark context object, and this serves to a group of RDDs and the shared variables. An application can run more than one job either in series or in parallel, and provides the mechanism for the job to access an RDD which was cached by the previous job in the same application. RDDs, whenever I am trying to work with the data set, say for example I have divided my job into stages, and the first stage is divided into 3 tasks, say for example, and I was working with, in stage 1 I was working with employee table. Next stage I might be working with department table. Stage 3 again I want to access the employee table. Just for analogy I am trying to give this example. In such case, stage 1, when it is working with employee table, after finishing its work, it will try to hold that particular employee table in the cache memory. So when stage 3 wants to access the same table, I need not load it back from the hard disk. I can directly use from the cache memory just to save the processing time, right? Now if you see one single application which we started discussing from the data set onwards, whenever I want to access the maximum temperature of the quality code among 0, 1, 4, 5, 9, any one of these quality codes, we kept on seeing this application under various frameworks we were seeing. Now the same application, if we are writing in Scala, that looks like this. I told Spark provides APIs to write the applications in Scala, Java, Python. So the same application I will show how it will be written in Java and how it will be written in Python. So this is the Scala notation for the application wherein you are trying to find out maximum temperature using spark. So, the same application, if I try to write in Java using Spark notations, it looks like this. The same thing we are trying to write in Python, it looks like this. So, when you are trying to work with Python, they make use of lambda functions, map functions, high order functions, whatever you feel like. So, you can make use of those functions. So, the same program, if you try to see, it is written in Scala, written in Java and Python notations, and how are we executing? Now, I was talking about RDD. RDD means resilient distributed data set. Spark totally revolves around these RDDs. So, whatever the concepts we are learning under Spark, that will be revolving around these RDDs, and very important with respect to your examination point of view and practical examination also, they will ask you to use the RDDs. How do you define RDDs? You have various practical questions also based on Spark RDDs. So, just try to concentrate what are RDDs. RDDs or the resilient distributed data sets are the heart of every Spark program, and we can create them in 3 ways. RDDs can be created in 3 ways. What is the first one? From an in-memory collection of objects. Already some objects are there in the cache memory. Using them you can define an RDD. This is called as parallelizing a collection. A collection is there in memory, I am trying to define a parallel RDD for that. What is the second option? Using a data set from an external storage. Generally we try to access the data from HDFS and try to build an RDD for that. Third option, transforming an existing RDD. Already an RDD is there, you apply some transformation just to make some changes. So, you are trying to transform an existing RDD in order to create a new RDD, right. So, these are the 3 ways of creating RDDs. The first way is useful for doing CPU intensive computations on small amounts of input data in parallel. So, whenever you are trying to work with CPU intensive jobs, you try to go for the first way of creating the RDDs. Now, whenever you are trying to work with RDDs, just try to understand. For example, I try to explain this concept with this particular example. For example, the following runs separate computations on the numbers from 1 to 10. Ma'am, 1 to 10 is a very smaller data set. Just for example purpose, I have taken a smaller data set. You are trying to define val parameters is equal to SC. SC stands for Spark context. SC dot parallelize 1 to 10. So, what do you say? Take my data set 1 to 10, those are the numbers. Please execute them in parallel, right. The result is equal to params dot map. So, it has to map perform expensive computation. So, you are trying to use an object perform expensive computation, which is a function, and it can run on input values in parallel. So, you are trying to say params dot map, even though you might think we are calling the map function, it internally calls the perform expensive computation method. And because you are saying please execute them in parallel, the level of parallelism is determined by Spark dot default dot parallelism property, which can be set. What is it equal to? What are the default values for spark dot default dot parallelism. Generally, two default values can be defined. First one, spark dot default dot parallelism is equal to number of cores on the machine if you are executing the job in a local system. Say for example, I have installed Spark on my system which is not into any of the distributed network. In such case, what is the default parallelism count, which is equal to number of cores in my machine. Say for example, I have 5 cores. So, the default parallelism, 5 jobs can be defined parallelly, right. On the other hand, suppose you are working in a distributed environment. In such a case, when you are working in a distributed cluster, that is equal to number of cores on all executor machines. So, if I am working in a distributed environment, if I have 1500 executor machines, if all 1500 are eligible to execute my program parallelly. So, in such case, spark dot default dot parallelism will be number of cores on all executor machines. So, in my example it would be 1500. So, the parallelism count differs from when you are working the job on a local machine or when you are working it on a cluster. I am not happy with the number of cores. You definitely have an option to define the parallelize count can be defined here. So, what did I define here? SC dot parallelize, spark context dot parallel values. What are the input values? 1 to 10 should be divided into how many parallel jobs? 10. So, in such case it defines 10 number of jobs irrespective of the cores you have in the environment where you are executing the jobs. This is the first way, previous one was the first way. Second one, we have seen we can try to create an RDD from an external file. So, when you are trying to define RDDs from an external data set, default you can try to take the data set from HDFS, which is a default text file. So, you specify the input path, it will try to create an RDD for the text file you have specified. Also, when you are trying to specify and you are taking the data set from HDFS, it will go for the default number of splits. Whatever the file is there, how many number of splits it should be dividing, it follows the default split size and number of splits are defined. But you are not happy with the number of splits, you want to specify the number of splits, you can specify sc dot text file, the input path, whatever file I am using should be split into 10 splits. So, you are explicitly have a chance of specifying the number of splits your file should be divided into. If not text files, Spark can also try to take from sequence files also. This is how you specify how it has to create an RDD from the sequence files. And whenever we are working with creating RDDs from an Hadoop input format, you have Hadoop file when you are trying to specify the path. For path not specified files, you can use directly Hadoop RDD method. Also, when you are using the old MapReduce API, you can use these two methods. If we are working with new MapReduce methods, these are the methods to be used in order to create the RDDs from the external data sets. So, this is how we try to, this is an example of creating an RDD from an Avro file. So, we are trying to take the data from Avro file. Thank you.